All right, students, this is lesson 8.6. We're learning how to factor polynomials. In this lesson, we're going to learn how to factor polynomials that have a number other than 1 for the a term. Go ahead and do this review, and you can check back with your answers. All right, we're going to learn how to factor trinomials that have a term at the beginning, a coefficient other than 1, which makes it a little more difficult. We end up with a lot more possibilities. And I'll explain more about this tomorrow in class, but basically, when we had a coefficient of 1 there, we could do things like, all we had to do was find two numbers that had a product of 5 and a sum of 6, so that was a little bit easier. Like this one would be the quantity x plus 1 times quantity x plus 5. So we're just looking for a product of 5 and a sum of 6 for our factors. Now we're looking for two numbers that have a product of what these two coefficients are multiplied together, which is 6, and have a sum of 7. So we're looking for two numbers that multiply together equals 6, so it's either 1 and 6 or 2 and 3. And then they have to have a sum of 7, so in this case 1 plus 6 is 7. So that's the pair we want. And what we're going to do is rewrite this then just rewrite this as the 4 terms that we get when we multiply out the two binomials using the 1 and the 6. So we're going to rewrite 7x as 6x plus 1x. And we could write it the other way too. We could do 1x plus 6x if we wanted to. Then we're going to factor each of these pairs individually. So if you look at 3x squared and 6x, the greatest common factor of those two numbers is 3x. So I'm going to factor out 3x there. And when I do that, I get, in parentheses, x plus 2. And the second pair here, the greatest common factor there is 1, so I'm just going to factor out a 1. And I'm left with x plus 2. And notice what happens when we do that. We end up with a common factor in both those terms of x plus 2. So one of my factors is x plus 2, and the other factor using the distributive property is 3x plus 1. So the important thing to remember there is to find out what numbers you're going to use to split up the middle term. You have to multiply the coefficient of the first term and the coefficient of the last term. So 3 times 2 is 6. That's the product you need, and then you need to think of two numbers that have 6 as a product and 7 as a sum, because we need two numbers to add up to that 7. All right, so go ahead, you try it. I'll just give you a hint on this one quick. So first thing you're going to do is multiply 6 times 5 and get 30, and look for two numbers that have a factor that have a product of 30 and a sum of 13. Go ahead and try it. So the only difference here is now we have some negative numbers involved, so we have to think about factors in terms of negatives also here. So, but we're going to do it the same way. We're going to try and think of two numbers that have a product of 2 times -3, which is -6, and have a sum of -1. Remember, the coefficient is 1 if there is no coefficient showing. So we are going to try and think of numbers that have a product of -6, like 3 and -2, or -2 and -3 and 2. Actually, we don't even need to think about this because we need a negative here, so we need the negative factor to have a greater absolute value than the positive factor. And then so our other choice would be -6 and 1. And just think about that, which of these have a sum of -1? And it's these two. So we're going to rewrite this as 2x squared minus 3x plus 2x minus 3. Like I said before, you could actually have 2x minus 3x there. That part doesn't really matter. Then we're going to factor out these two terms, the greatest common factor, which is x. And so we get x times 2x, and then x times 3. And then 2x minus 3, the greatest common factor there is 1, so we'll factor that out. And we get 2x minus 3. And you can see that we have a common factor here of 2x minus 3. So that's one of our factors, and our other factor is x plus 1. All right, go ahead, you try that. All right, so here's how we apply this idea. We have the area of a rectangle is 4x squared minus 7x minus 15. The width of the rectangle is x minus 3. We know that the area is equal to the length times the width. We're given the width is x minus 3, so that's one of the factors. So the length is something times x minus 3 that equals 4x squared minus 7x minus 15. Well, to get 4x squared, we know we have to multiply x times 4x. And to get minus 15, we know we have to multiply positive 5 times negative 3. Then we just have to check to make sure the middle term works out. We need to get negative 7 when we add the outer 2 plus the inner 2. The outer 2 here give us negative 12x, and the inners give us 5x, and when we add those two together, we get negative 7x, so we're good. Go ahead, you try that. All right, sometimes you can factor out a monomial first to make your job of factoring a little bit easier. If we wanted to in this problem, we could go ahead and multiply 30 times negative 8, which is negative 240, and then look for two factors of negative 240 that add to 14. But negative 240 has a lot of factors, so it might take a while. But one thing I noticed about this is that all these numbers are even, which means we can factor out a 2 out of all of those first. So I'm going to do that. So I get 2 times 15x squared plus 7x minus 4 is the same as 30x squared plus 14x minus 8. Now I have a little easier job of factoring. I just need two numbers that have a product of negative 60. 15 times negative 4 is negative 60, and have a sum of 7. And since that number is positive, I need my positive number to be greater than the absolute value of the negative number. So I'm going to look at factors of negative 60, like 60 and negative 1, 30 and negative 2, 20 and negative 3, and I'm going to keep doing this until I get two that add up to 7. 15 times negative 4, that's not it. 12 times negative 5 is 60. There it is. 12 plus negative 5 is 7, so that's what I want to use. So I'm going to do 2, and then in the parentheses here I'm going to have 15x squared plus 12x minus 5x minus 4. Now I'm going to factor that. I'm going to get 2 times, let's see, it looks like 3x would be my greatest common factor there. 3x times 5x plus 4. And then out of these two, the greatest common factor there is, I'm going to actually factor out a negative 1. I think I need to do that to get the plus 4. So negative 1 times 5x plus 4 works. All right, and now I can rewrite this using the distributive property. We have 3x minus 1 is one of the factors, and 5x plus 4 is the other factor. All right, so go ahead, you try that. All right, go ahead and do the lesson check here. Explain why you cannot factor the trinomial 2x squared plus 7x plus 10. Actually, I'll do this with you, help you out. So for the first one, we have 2x squared plus 9x plus 10. Can you factor out a monomial from the polynomial? No, because 2x squared, 9x, and 10, the greatest common factor of all those is 1. So can you rewrite 9 as the sum of two factors of 20? Yes, you can, because the two factors of 20, let's see, two factors of 20, we could do 20 and 1, those don't add up to 9. We could do 10 and 2, those don't add up to 9. We could do 5 and 4, those do add up to 9. So the answer there is yes. So can we factor that? Yes, we can. Now, let's consider the polynomial 2x squared plus 7x plus 10. Again, we cannot factor out a monomial because the greatest common factor of the terms is 1. Can you rewrite 7 as the sum of two factors of 20? Well, we already have all of them up here, and none of those pairs add up to 7, so the answer there is no. So 2x squared plus 7x plus 10 is considered factored completely because there are no numbers that have a product of 20 and a sum of 7. So that's the lesson. I'll see you tomorrow.